Our first speaker is Colin Vernon. For the past 2 years, Colin has led the engineering team at LittleBits, whose mission is to make learning about electronics fun.
I want to talk about technology. So, technology these days. It's crazy, technology these days. When we talk about technology, we talk about a very specific type of technology. It's like this kind of stuff. It's fancy electronics and robots and it's electronics. It's about electricity. The difference between how we're thinking about technology and between 2010 and 2014 is somebody spends 7 hours a day on computers or 11 hours a day in digital media now. And mostly that ends up looking like this. This is the next thing of what technology means, is the Internet of Things, and we're fascinated a little bit with construction techniques or physical, mechanical engineering, but mostly we're talking about electronics. And when we buy electronics and we consume electronics, they look like this, and we don't have any really access into what they are or what they do. And when we create electronics, it looks like this, and I don't know what that machine is doing, and I certainly don't know how to interact with that machine or make this thing into something that I want it to be instead of the thing that whatever it's supposed to do. So a little bit, we really want to put the power of electronics into everyone's hands. We see so much the spectrum of, on the one side, it's closed and you have one function and you can't repurpose it. And on the other side, well, there's no other side. That's the thing. There's no other side. We don't know how to interact with technology. We don't understand it beyond the simple function that is presented to us. So how you understand something is you break it down. You break it down into pieces that you can understand, and you get the right abstraction. This is how people communicate technical concepts or complicated concepts of any sort. You break it down into pieces, and you get the right kind of abstraction to understand the concept. So the whole idea of LittleBits is about electronics alphabet. It's about taking the specific functions and specific interactions and pre-engineering them into little electronics modules that snap together with magnets. And so as far as breaking into concepts and categories of useful things, we break it into power, because it's electricity, it's electronics, you need power. Those are blue ones. The green ones are output, so motors or lights or anything that creates motion or action in the world. Inputs are anything that modify the output, so there can be kind of direct buttons or sliders, or environmental things, motion sensors, sound sensors, light sensors. These ones can get more complicated. And then wires, of course, wires just join things together, but the whole wire concept is kind of a bucket category of things that modify, and they can get, a simple wire, you can branch and fork and split, but also analog logic gates, so like ANDs and NORs and this kind of thing that are really the basis of all the computers that we have, is about just gates and switching and on and off and simple electric logic. And then we go even more complicated on the orange ones, so they get programming. We have a collaboration with Arduino and have a programmable module. And then what was mentioned in the intro, the cloud bit, is the internet connected module, and that's kind of a wire between the hardware and the internet, and either other hardware or web services or whatever. So the wire is an interesting category, and it's about making connections. We think of this as a physical API. There's an agreement of how the words are going to go together, and that's kind of how we think of a grammar. Electronics should be a material in the way that a cardboard, a paper, a paint, metal, wood, these are materials in the world, and people, you understand what they are and how they work, and you understand how to deploy them and build, use them to build more complicated things. Really, then, the idea is about understanding. You get a concept, break it down, I can understand it. Once I have this understanding of a concept, I know what to do with it. I'm empowered by that. I can think about new things, and I can innovate. I can really create new stuff. I can use the grammar and the words and the letters to create new writing, and I can make my own language. I can write my own book that I want instead of just reading the books that are given to me. Very much, again, the goal is lowering the barrier to creation with electronics. And we have a lot of people in intro to physical computing, to adults and thinkers, everything. The kind of foundation of being able to create with electronics shouldn't be limited by your kind of technical engineering know-how. In the physical realm, there's just kind of really simple. There's like a motor, and this crayon turns really slowly, and it's a kind of a child-safe lathe. Another really simple one is taking a little motor and a cone of paper and a needle, and then This one is crazy. It's a 9-year-old in Korea who used like 2 light sensors and LEDs. It's a really classic robotics problem of the line-following robot, and there's a million ways to solve it, but that's really cool. As we were taking on the whole realm of music technology, we made what I think is the world's smallest and awesomest modular analog synthesizer in collaboration with Korg, but also the the low floor, high ceiling concept of that it's super easy to take these concepts of snap together oscillator and sequencer and this kind of stuff, but then integrate it into other stuff that is more complicated. So again, it's not about the technology, it's about what people want to do with it and what people want to do that they're not going to get necessarily out of a package, or they're not. It's people creating their own world. The next real one that I'm personally really involved in is the cloud bit and the software architecture behind the services and the connection methods and the whole kind of ecosystem around it. And then so what it does is input and output. Everything is just about simple input output, but this gives you a really no programming, no soldering, just like direct snappable interface between the hardware. So you can have input from any kind of hardware device that you have. It could be a motion sensor or anything basically. Being a modular system, have that go up to a cloud platform and then send to any web service. It's fascinating what people do when you understand something and you have the tools to make buttermilk. It's crazy. The understanding to know what it is, the empowerment of like, yes, I can do something, the inspiration that's coming from this a massive community at this point, but the inspiration that comes from just a mass of people having an understanding and a shared toolkit of basic electronics over time is the innovation that comes from that. We've seen people pitch to investors first prototypes and get money based on a little bits prototype and then go on to make a more kind of professionally engineered product, and just the range of stuff that happens is really fascinating to me. Understanding the language of electronics will let people write their own poetry, and that's really the idea of that any particular tool is just a piece. And that's what people do with it. It's being able to deploy it in their own way and say that their own story. That's the part that that's really what we're here for.